Hi, my name is Kerem and I'm a third year electrical and electronics engineering student at Meta.
Hi, I'm Sıla. I'm also a third year EE student at here. And this presentation will be used to demonstrate the milestone of our micro air conditioner project. And we will provide some general overview of the project.
So the overall system we are designing is basically an air conditioner, which is capable of both heating and cooling a small space. And the overall system architecture consists of 5 subunits, namely the sensing unit, adjustment unit, control unit, and the operation unit, which consists of heater and cooler. So let's start with the sensing unit. Well, we need this unit because we need a measurement from the ambient temperature to be able to control it. And we visualize this ambient temperature with the RGB. And as suggested, we will be using LM35 as the temperature sensor. The other unit is the display unit, which again visualized with the RGB and also implemented as the milestone, which we will be showing again at the end of the video. And this unit covers a range from 24 degrees to 40 degrees, basically. The other unit is the control unit. This unit takes two temperature values from the sensing and adjustment units and compares and with that comparison decides if it should turn on the heater, cooler, or neither of them, basically. And as the control method, we will be using first at least bang controller or the on-off controller as suggested. But if we are not able to achieve the additional constraints, we will be trying the PID or more advanced control methodologies to have better control basically. The other unit is the operation unit, where we will be having stone resistor for heating and 12-volt DC fan for cooling. And as suggested, we will be placing the temperature sensor on top of the stone resistor. And for when it comes to fan, we'll be trying to put the fan as close as possible to the temperature sensor to have a higher velocity over the temperature sensor. But if we are not able to achieve these constraints, well, we thought of having maybe a nozzle, which on the larger area, we will be putting the fan and the smaller area we'll be putting the temp sensor on the smaller area. And this nozzle, the objective of this nozzle is to increase the air velocity, which will again be increasing the convection heat transfer rate from the overall system. And maybe with that logic, at worst case scenario, maybe we can achieve these constraints and have better control.
So yeah, we came to the milestone of this project, which contains the temperature adjustment and the display units, and they are very critical for the user feedback since their values are fed into the control unit. So we decided to use two RGB LEDs to indicate the set and the ambient temperature. And the color on the RGB LED will cover the entire here visible spectrum in a continuous manner. And for example, here it will show blue at 24 degree and it will show red at 40 degree and it will show green at 32 degree, and below 24 degree it will still show blue, and above 40 degree it will still show red on the RGB as required in the project description. So our design for the display unit focuses on analog control of the individual RGB LED currents, which allows for this continuous color change. And we are using a combination of circuits which consists of some configurations, different configurations of op-amps. And the purpose is to translate the input voltage level, which is representing the temperature, into the specific current mix for the red, green, and blue pin of the LED. So this ensures a smooth color transition, and this is what we will demonstrate in the milestone video. So now let's show the milestone implementation. We are simulating the temperature input with a variable voltage, which is controlled by a potentiometer for the set temperature. And as we turn the potentiometer, as you can see, the input voltage is changing, and this corresponds to the desired temperature level. And RGB's colors also change continuously. Starting from blue at the minimum setting, as I increase the inputs, we move to the cyan, green, yellow, and finally red at the maximum input. So this continuous color change demonstrates the display unit based on the set temperature input. So to conclude, we have successfully implemented and demonstrated the continuous color output for the set temperature using the RGB LED. Thank you.
Thank you.